Hello. So as I said at the end of the previous video, from here, we are going to study how to convert conditional probability into the joint probability distribution. So I'll consider another example. Suppose that you are the CEO of a quality control manager at a smartphone factory. So I'll assume that a smartphone manufacturer is concerned about defective batteries. And I'll simplify the example. Of course, again, the numbers are just fake, made-up numbers. I assume that in a smartphone, 60% of batteries are domestically produced, and the other 40% are imported. And we are going to denote three events like this, like two events basically. D stands for domestic battery. And then imported battery is automatically the complement, right? And I will denote defective battery as F, faulty battery. So, of course, F complement will be good battery, okay? So I am interested in the defects in the battery in the final products. So the information we have is given like this. We know that domestic batteries are defective with 2% probability. But imported batteries are more defective, more likely to be defective with probability 7%. So then my first question is, how do you express this information using our notation? Think about that. So this is not an algebra question. It's how you translate casual words into statistical notation. The answer is like this. Say, first, let's think about the first sentence. 2% is like probably like this. So think about the experiment. Underlying experiment is like this. Here you have a bunch of domestic batteries. So you know that all these batteries are domestically produced. And you are randomly choosing one of them and check if the battery is defective or not. That probability is 2%, okay? So here in this experiment, what you know is the condition is that you already know that those batteries are all domestically produced. So domestically produced batteries is the conditioning event. You know that the condition is D, domestic batteries. So when you know that they are domestic batteries, and then you randomly choose one of them, and you are interested in the probability of defective batteries. So F is the main event. So the first sentence can be written as 2%. I mean, conditional probability like this, which equals to 2%. Okay? Similarly, the second sentence can be understood this way. Everything is the same, but the condition is different. Because now you know that the pool you are choosing from consists of only imported batteries. So only imported batteries are in front of you, and then you choose one from them. So the condition changes, but basically the same probability of defective batteries. So the answer is C. 7% is the probability that a battery is defective given the condition that the battery is imported. Okay? So that's how we translate these sentences to statistics. Okay, so this is exactly what I explained. Okay. This is the information. Say again, you are the CEO. You are taking care of the quality, final quality. But you don't care. It's not important whether the battery is domestic or imported. So what actually matters is the overall defect rate. Okay. So then this is exactly the situation I described. You have the information as the CEO. The reports are about conditional probability, right? The information you have is based on different conditions, domestic batteries, imported batteries. And based on them, what matters actually to you is the overall defect rate. I don't know if my smartphone has like a domestic battery or imported battery. Consumers don't care about that. Just it's a matter of defects, right? That's one thing. And another interesting question is the other conditioning. Like, so we learned probability of F given D. But what if you want to flip the events? So if you want probability of domestic batteries given defective batteries, among defective batteries, how can we calculate this information based on these two informations? This is the main topic we are going to learn in this video, okay? And simply speaking, okay, even though I said something very complicated, but the basic idea is we would like to recover the joint probability distribution. If we recover the joint distribution table, like as we did X, Y, Z, W, unknowns, and solve for the unknowns based on these informations, then you know everything. If you know all the joint probabilities, then you can calculate conditional probabilities as we exercised, as we learned in previous videos. So understanding the joint probability distribution is everything. That's the complete knowledge about these two events. Okay? And then how do we do this? Later, at the end of this video, at the end of these things, I'm going to show you a formula, but the formula is very complicated. It seems very complicated. So instead, I'm going to show you another method which is more intuitively understandable, right? So let me put it this way. As I said, it's kind of like inspection of batteries. So you imagine the real inspection situation. So I'm going to imagine that in front of you there are a lot of batteries. Say, fix the number. Suppose that you have 1,000 batteries, or you can imagine million or billion batteries. But just to simplify the algebra, I'm going to use 1,000. And then what you are going to do is you are going to classify those batteries into 4 types. So as I said, you are going to fill in these numbers. So that means there are 4 types of batteries. So if you can classify 1,000 pool of 1,000 batteries into 4 types, then that is basically this table. The ratio of each type becomes the probability. So that is what we are going to do. We are going to classify those 1,000 batteries into 4 categories. And when you classify them, divide them into different types, we are going to use the given information. Of course, we do this in our imagination. It's like a mind experiment, but it's very interesting. Let's see. We start from 1,000 batteries. As I said, it doesn't need to be 1,000. You may choose million, billion, or you may choose 100, or you may choose, say, 365 batteries. Any number is okay, but of course we want to simplify the algebra, so that's why I chose 1,000. And then first, we are going to classify those batteries into domestic batteries and imported batteries, right? By the way, I like at the beginning of this example, I gave you the overall proportion between domestic and imported batteries. So there are 60% and 40%. So based on that probability, I'm going to divide the pile of big pile of batteries into domestic battery pile and imported battery pile. In domestic batteries are 60%. 60% are domestic. Therefore, out of 1,000, you are going to have 600 domestic batteries, right? So put them on this side. And imported batteries on the other side. So there are 400 batteries on here. So you divide 1,000 batteries into two piles. And then, now look at the domestic batteries. And we are going to classify them into defective batteries and non-defective batteries. So what we are going to use is the conditional probability for domestic batteries. So conditioning on domestic batteries, defective rate is 2%. Exactly, that's what we are going to use in our division, right? So in this classification, we know that 2% of 600 domestic batteries are defective. So there will be 12 batteries that are defective. So 12 out of 600 is 2%. So we get 12 defective domestic batteries. That is first type, right? And then once you pick up 12 batteries out of 600, then the other batteries are good batteries, okay batteries. So then automatically the number is 588. So you already made two bunches, two piles of batteries. They are two of the four types. We are going to do the same thing for the other side of the imported batteries. There are 400 imported batteries. Now you have to use 7% because the information, you know the information that 7% of imported batteries are defective. So that means out of 400, 7% equals 28. So 28 batteries are defective, right? So pick up 28 batteries, and then the remaining ones are 372. They are non-defective. So in the end, so I believe you understand what I'm doing. So then in the end, we classified a total 1,000 batteries into four types, four categories. This is exactly what you wanted. So just what you need to do is you can use them as kind of data, imaginary data, or just so using them as data and then fill up this table. That's what you have to do. I believe that is a pretty straightforward process. So I will ask you this question. By the way, one more thing. By the way, what's important here is once you choose 1,000 number, 1,000, and then you first apply unconditional probability. So I first divide the whole batteries into domestic and imported. That is the first step, and then divide them into defective and non-defective. You cannot change the order because the reason why I divide them into domestic and imported first is because that is given as an unconditional probability. But the event of defects is given as conditional probability, so it should come as second classification. So you have to know that something is domestic to apply the conditional probability. Therefore, you have to divide the batteries into domestic and imported first, and then you may apply the conditional probabilities. And different conditional probabilities are used for different conditions, right? Obvious. So if the given information was in a different form of conditional probabilities, then you may choose different order of classifications, but that's but in this example, we are given unconditional probability for domestic and imported batteries, and then conditional batteries for defective and non-defective batteries. So that's the reason why we classify the batteries in this order. Domestic and imported first, and then defective and non-defective, right? So that's that. And so anyhow, again, you know the 4 types, the ratio of each type, and then you can fill the joint distribution table, or you may just use them as frequency, right? It's kind of frequency table, and then based on that, determine the unconditional probability of defective batteries. So to give you some time to calculate this, I will stop the video here. So once you finish this calculation, please start the next video. Okay? So see you in the next one. Do this question. Bye.